Hi again. Now we're going to continue by the equation of cylinder, circle, and sphere. You know, from before, these equations are used to be the equation of circles. Now it's not anymore equation of circles in 3 dimension. It's equation of cylinders. So let us go to GeoGebra, and so that you will understand. By GeoGebra, it will understand more because the picture will be in front of you. Suppose I want to graph x minus 2 square plus y plus 1 square equal to 4. Equal to 4. So this is nothing else than a cylinder. The cylinder has center 2, 1, 0. 2, 1 because we put x minus 2 square, so 2. Y plus 1 square, and y equal minus 1. 2 minus 1. Because I don't have z, so 0. This is the center. We're going to put it 1. I equal 2, 1, 0. 2 minus 1, 0. Okay, so you can see it in the middle. This cylinder is perpendicular to the y plane, as we did like before, and parallel to the missing one, which is the z. So this is the z axis. You can see it here. This is the z axis. It's parallel to the z axis, perpendicular to the plane xy plane. So if I want to take another one, for example, suppose I want to take, for example, x plus 2 square, x plus 2 square plus z minus 1 square equal to 9. So it's also a cylinder, but here, since we have missing y, it's parallel to the green line y and perpendicular to the xz plane. So anytime from now and on, when you have like this in 3 dimensional, these are not equation of circles. These are equation of plane. How to find the equation of a circle? To find an equation of a circle, we need to find the intersection of a cylinder with a plane. And let us go back to the GeoGebra. Suppose I want to take the first one because the first one. Suppose here, what's missing in the first one? What's missing in the first one, as you can see, is the z. Suppose I pick any elevation of z. I want the plane z. You know that z equal to 3. It means it's a plane perpendicular to the z axis. Like here, it's perpendicular to, for example, in part A, perpendicular to xy. Here, perpendicular to the z axis and parallel to the x or y plane. Okay, you can see this plane here. So you can see that the intersection between the two is a circle. So if you go and write intersection, so intersection between object, I have object A and object C, small a and c. You're going to get what? Let me delete everything except the object. You're going to get a circle. So the circle here is the intersection of this cylinder with this plane. So if do the intersection to get a circle in 3 dimensional, you cannot do it directly. You need to find intersection between a cylinder and a plane, and such that if you have the cylinder, in the cylinder you must have two variables, xy or yz or zx. If you have xy, the equation of the plane must be z equals something. Okay, in that case here, what will be the center? The center of this circle will be, I have the equation here, x squared minus 4x. So the center of I for the x is 2. For the y, I have y squared plus 2y. If you divide the coefficient by 2 opposite sign, it will be minus 1. And for z, you take the elevation, which is z equal to 3. So in that case, as you can see, if you have this point, I2 minus 3, you're going to see, let me delete and keep the circle. You can see that this is the equation of a circle, and this is its center, and its radius is what? Its radius here, as we said before, is equal to 2. Okay, so this circle is perpendicular to z equal to 3, perpendicular to z equal to 3, parallel to the x or y plane, and its elevation is 3, and it's perpendicular to z equal to 3 at the point what? 3. Okay, so if you want to take more examples of that, let us take another equation. Suppose, let me take the second one. this plane. Here in this plane, it's missing what? Y. So let me pick y equal -2. So this is y equal -2. So the intersection, as you can see, between the two is a circle. If you put intersection between object and object, we have object B and object E. Object B and object E. You're going to get the circle. And if you want to find the center, what I know directly now, center F, I know its elevation, well, its y must be -2. So you can see -2. And if you do here canonical form for this one, you're going to get, if you write it as parenthesis square, you have x is -2, y is 1, z is 1, and y is -2. So as you can see, this circle here, that you have it here, first of all, because I have this plane here, this cylinder, as you can see, I don't have y. Okay, it's an intersection between this cylinder and this y equal -2. So this circle that we have found is perpendicular to the y-axis at y equal -2 and perpendicular to the xz plane and perpendicular to the xz plane. So here, that's what you can read it by yourself. If you have like that form, it's a circle. Why? Because it's the intersection between that cylinder and the plane z equal to c. It's a circle whose center is a, comma b, comma c, perpendicular to the z-axis at z equal to c. Here, it's a circle which is the intersection between this cylinder and that plane, whose center is a, b, because y is b, and z is c. Radius r, perpendicular to the y-axis at the point y equal to b, and this one. A sphere equation, an equation of a sphere, guys, to finish from that, let me go to the GeoGebra. If you want to find the equation of a sphere, let me return it back to. So sphere, so you have x, y, z all together. So for example, you may have x -2 square plus y, for example, I'm taking an example, square, for example, plus z square equal to 9. So here, this is a sphere whose center is 2, -1, and 0. 2, -1, 0, and radius is what? 3. Okay, so this is my sphere. Center 2, -1, 0. And if you want to check about the center of this conic of A, this sphere, this is the center of the sphere. You may have a sphere, if you put less or equal to 9, it will be the inner. Okay, it will not take it. So less or equal to 9, it will be inside the periphery. Bigger or equal to 9, outside the periphery. And equal, it will be the periphery. So this is a sphere. Okay. Here, some applications. Interpret this equation. Z bigger or equal to 0, it means the 4 octant, the upper 4 octant, everything up. So they have space consisting of the points and above the xy plane. X equal -3, we know it's a plane perpendicular to the x-axis and parallel to the y or z-axis, but perpendicular to the x-axis at the point at x equal -3. So here you do x -3 and you do the perpendicular of the plane. Z equal to 0 is nothing else than a plane perpendicular to the z at 0. This is the z. Perpendicular to z at 0 is nothing else the base down, the x or y plane. So it's the x or y plane. You want x to be negative. This is the x negative before, and y positive. So what do you get? This quarter of the plane, this part here of the plane, quarter of a plane. So where you can see the cursor here. I want a plane y between -1 and 1. So the plane y between -1 and 1. So let me go to the GeoGebra. You graph y equal -1. So this is y equal -1. And this is y equal to 1. It will be everything this all part between -1, it's like a block, it's like rectangular box from between -1 and 1, like a rectangular box. Okay, so we call this slab between the planes -1 and 1. Planes included y because you have equal. Y equal to -2, we all know it's a plane perpendicular to the y-axis at y equal -2. And you have z equal to 2 is another plane. So we have intersection between two planes. The intersection between two planes is a line because let me graph it, GeoGebra. You have y equal -2 and z equal to 2. Let us go to GeoGebra. Y equal -2 and z equal to 2. So the intersection, as you can see, is a line. This line is passing by which point? It's passing by the point 0, -2 and 2. But this line is nothing else, a line parallel to, because I don't have here, you can see I have y and z, I don't have x, parallel to the x-axis. Parallel to the x-axis, because this plane is perpendicular to the x or y plane. This plane is perpendicular to y or z plane. So the common line, which is that line, will be perpendicular, but will be parallel to the one missing, which is the x-axis, and passing by which point? Passing by the point 0, -2, 2. So if you put, for example, a here, another a because I have a up, b equal 0, -2 and 2, you can see that this line passing by this line but parallel to the x plane. Okay, so for example, what points of P satisfy? We all know that this is a cylinder, this is a plane, so it will be a circle whose center is 0, 0, 3, radius is 2, and the circle is perpendicular to z-axis at the point y equal to 3. You can see it here, 0, 0, 3. Okay, you can draw it by GeoGebra. The distance, you know the distance from before, be two-dimensional. Three-dimensional is the same, xa minus xb squared plus ya minus yb squared plus za minus zb squared. Don't forget to put the square root. And if you want to find the center here, you take the x's together, you divide the coefficient of x by 2, then you do minus the number square, canonical form. Y, I don't have, I have y square only. Z here, you divide z by 2, it will be -2, you square it, you take the numbers to the other side, it will be a sphere of center -3/2, 0, 2, and whose radius 21/4. You can check it by putting this in GeoGebra. What I mean here, if you go to GeoGebra and you write this equation, you can find the center, check your work. So here, if you graph it as it is, x squared plus y squared plus z squared plus 3x minus 4z plus 1 equal to 0. So if you put center of the conic F, as we said, this is the center. If you put radius of conic F, you're going to get its radius, which is 2.29. Okay. Now I gave you problems. You can solve it by yourself. I will wait some seconds for each one so that you can picture it. Another kind of problems. Here more problems. Here you have the answer key. You can check it by yourself. So here, answer key. Continuation, it's 58 problems. Answer key and answer key. So I hope that you got the three-dimensional coordinate system. We talk about circles, about spheres, about cylinders, about planes, locating points, locating. So I will see you in the second video. It's going to be about vectors, vector sum, vector product, graphing vectors. So see you in the coming videos.